So I have here the definition of what it means for two triangles to be similar. But what I'd like to do is kind of take a step back and walk through this and see if we just can't kind of intuitively figure out what it is it's talking about. So first, we've kept the requirement that the angles have to be the same, which guarantees that the two figures are going to have the same general shape. But we've relaxed the requirement that the sides have to be the same, only specifying that they have to be proportional. So put together, this means that similar triangles have the same shape, but a different scale, which is what you see with these two figures here, where one is just a scaled up or scaled down version of the other. Now, to see how we can go about showing that triangles are similar, we need to add some more details, right? So first, we have to have pairs of congruent angles, which we have here. And second, the corresponding pairs of sides have to be proportional. What that means is that if we take a pair of corresponding sides and divide one by the other, for example, 6 and 3, we get the same value from every pair. So if I do this with the 10 and the 5, we get 2 again. And if I do this with the 12 and the 6, we get 2. So thinking about our idea of having the same shape but on a different scale, what we're seeing here is that the first triangle has the same shape as the second one, but its sides are all twice as long. Or you can look at it the other way and think of the sides of the smaller triangle as being half the size of the larger one. Just when we're talking about congruence, proving similarity using the definition can be a little tedious. There's an awful lot of things we have to show, and it's a lot of work, and it turns out it's a lot of unnecessary work. Because just like we saw with congruence, we've got some theorems here that we can use to shortcut the process. So the first one, for example, the AA similarity theorem says, look, we don't have to actually show anything about the sides at all if we can show that we have two pairs of congruent sides, of congruent angles. That's enough to show that the two triangles are similar. The second one, you notice we're following the same pattern here, the way we use the letters, right? SAS means a side, another side, and the angle in between them. So this one is saying, look, if we can show that, and I don't want to mark these as congruent, right? I'm going to use a congruent symbol because that's more than we need to show. If I can show that the ratio of these two sides is the same as the ratio of these two sides, and the angle in between them, the angles in between them are congruent, again, that's enough, right? That would be sufficient to show those triangles are similar. And finally, we have another SSS theorem here. If we can show that the ratio of one pair of sides is the same as the ratio of a second pair of sides is the same as the ratio of a third pair of sides, that's going to force the angles to be congruent. That's enough to show similarity. Now, you notice there's also some similarity here in the letters. For example, we have both an SSS theorem for congruence and an SSS theorem for similarity. The congruence theorems, we usually just use the three letters and theorem and we're done. When we want to make it clear that we're talking about a similarity theorem, these are the ones where we usually explicitly qualify it and put similarity in the name. So in the next lecture, we're going to look at some examples and see how we can use these various theorems to actually show that some triangles are similar to each other.